So now that we've got the compute manager added, we're ready to get going with checking out our transport nodes. And let me show you first what the compute manager being added, what that actually did for us. So if you go over here to under Fabric, over to nodes, and then if we select manage by and drop that down, we'll see our compute manager we just added. If we didn't add that, we wouldn't see this output. So once I select it, you'll see it shows me my clusters within that vCenter. And if I expand it, it'll show things like the IP address of the host, the version of ESX it's running, which is important from a compatibility standpoint. It'll also show us things like, are the tunnels up and running? Does it have a TEP IP address? Is there any alarms on it, etc.? So these are all really important things, and I think the most important thing here is really around this right here, NSX configuration. It shows not configured. Now, the host where your edges sit does not have to be prepped for NSX because the bits that actually handle the overlay networking are contained inside of the edge VM. So the edge VM could actually sit on any host, and it doesn't have any special prep for NSX from a host standpoint because that's all contained in that edge VM. The hosts themselves, however, do have to have this special prep. And to do that, basically the way we do it is we can either select the cluster like this. Let me uncheck this. We can do this, and then we can hit configure NSX. It'll ask us for what we call a transport node profile. I'm not going to use this in this video, but basically these are really awesome for making one profile and deciding things like which VLAN should my tunnel endpoint or my overlay traffic be sitting on. And I only need one VLAN for that because remember, everything's encapsulated, so we can have many VNIs, many virtual networks over that one tunnel VLAN rather. Sorry, I can't talk. So as I mentioned, the transport node profiles are really cool. So if you had, say, 100 hosts and you wanted to change the TEP VLAN for all 100 hosts, you could actually just edit that transport node profile and it would push it to all of your hosts for you. So the way we're doing it is a little more manual, but it's also simpler, and I want to keep things simple for the sake of this video. So I'm going to cancel out of that. And I want to show you guys, so first I'm going to go in here and show you what kind of information it's asking for, and then we'll go build all of those prereq pieces of that information. So I will cancel out of it, but I just want to show you guys this. So I'm going to pick our first host, 254.11, and hit configure NSX. I'm going to hit next through here. Now, right away, I'm going to minimize this. You see it says add switch, and it shows new node switch. So NSX, there's a couple of ways we can handle actually pushing these switches to the host. So when you think about, you have a vSphere host, by default you kind of have two options. You have a standard switch or a distributed switch. Well, NSX introduces a couple of new options. One of those is called the NVDS, which is basically, it was recommended prior to 3.0. So that's kind of the old way of doing things, but it is definitely valid. And then we also include now the ability to leverage the existing VDS. Now, why would you go between one or the other? Well, it's really based on how easy it is to go with the existing VDS. Let's say I walked into your environment and you have a server that has 4 physical interfaces. If I tell you I want to install NSX and let's get it up and running, you're going to probably tell me, well, I have a VDS on this host already and I'm using all 4 uplinks. So the answer that I would respond with is, well, we'll take 2 of your uplinks away and we're going to give those to the NVDS because it has to own its own uplinks. It's basically another distributed switch. That's really the best way to think about it. So at this point now you have kind of your NVDS and your existing old VDS kind of sitting side by side, and honestly it's a little messy. So in 3.0 we introduced the ability to do what's called a converged VDS. Basically the idea is you can continue to use your existing VDS and NSX will just piggyback on top of that. Since this video series is all about 3.0, I'm going to show you the new way, but as I mentioned, doing the NVDS in kind of the old way is still totally valid. It's also worth mentioning that the edge node still uses a VDS, or an NVDS rather, inside of it. So that has not changed, so just keep that in mind. Now, as I mentioned, we're going to kind of just go through this and see what kind of information is required, and then we'll go build it and come back here and actually apply it. So you'll see here, as I mentioned, we kind of beat this to death, the NVDS versus VDS options. So we're going to stick with VDS, which is going to leverage that existing prod VDS that we configured a few videos ago. Then we're going to have to pick a mode. So enhanced data path is typically for network function virtualization or ISPs, that kind of thing. So I have not run into anybody that actually needed to use this, so stay with standard always. It's going to ask for a name, so that's just going to be some kind of name that is of the existing VDS on the host that we want to use. You'll see here it shows prod VDS, which is the one I configured previously. Next, it's going to ask for a transport zone. Now, I'm not going to explain what a transport zone is in this video because I've already done it in another video, so I'm going to put a link up here. And if you want to check it out, you guys are welcome to pause this video, go open up that video in a new tab. I think the video is only like 5 minutes long. It'll clear up the whole concept of a transport zone. Needless to say, we're going to have to create a couple of transport zones as part of this deployment, so we're going to do that soon. Next, it's going to ask for an uplink profile. This is basically specifying how many uplinks should I have, what VLAN should I use for my TEP interface, am I doing link aggregation or lags, and what should I set as far as MTU. That's really what the uplink profile is for. And we are going to need to create that because I am tagging all of my VLANs. So I'm going to be using VLAN 19 for that TEP VLAN. So we'll need to do that. If you're not tagging, you can actually leave these and you can map these to whatever port group you create. That's perfectly fine. But we're not going to do that. Next, it's going to ask for an IP. This is going to be the actual TEP IP or tunnel endpoint IP. You have a couple of options. You can create a pool. You can also create static IPs, or you can also let DHCP do its thing. I highly recommend for your transport nodes or your vSphere host to leverage DHCP where you can. It makes things a lot easier and you don't have to worry about running out of IPs or anything like that. Finally, since we didn't select an uplink profile, it doesn't let us map any links to them, but I'll show you what it would look like. So if I select, say, default uplink host switch profile, you'll see right off the bat, this profile is created assuming you have two uplinks. One is going to be active and one is going to be standby. Now, if you see here under VDS uplinks, if I click that, it's going to let me map over those uplinks in NSX to one of my physical interfaces on that VDS, on the host itself. As I mentioned, I'm not going to do that right now, so we'll come back to this. So I'm going to cancel out of this so we can build some of these components before we get started with actually configuring that host. As I mentioned, we do have to create the transport zone, so let's go ahead and do that first. The default installation of NSX-T does come with a couple of transport zones, which is really nice because the older versions didn't, and we'd have to go in here and create them, but it is really nice that these are here. However, I want to create my own. So I'm going to create two right off the bat. I'm going to create my first one is going to be a standard overlays transport zone, and I'll call that overlay TZ. I'm going to name my switch NSX VDS. And I'm going to leave it, I have two options, basically overlay and VLAN. This is going to be for overlay networks, so I'm going to leave that and hit add. Next, I'm going to create one specifically for my edge. This will make more sense once we get to the edge deployment, but I also did do another video you guys are welcome to check out on the edge deployment that will explain this piece a bit more, but needless to say, this is required. So for this one, I'm going to do edge, VLAN transport zone, and make that a VLAN traffic type, hit add. All right, so those are done. Next, we're going to need to go set up an uplink profile for this transport node. To do that, we're going to go over to Profiles, and we're going to hit Add. I'm going to give it a name, something that I will recognize. So I'm going to do MG, I'll do Transport Node Profile VLAN 19, and that should be good. Just something that I'll recognize very quickly. I'm not doing any lags, so I'll leave that the same. Default teaming. So the default teaming is always where your overlay traffic will essentially run over. So for that, in my case, I want to do active-active. So I'm going to do load balance source, not failover order. And I'm going to do all 4 links. So, and by the way, this is actually, these are just variables. As you saw on that previous screen, when I selected the default host switch profile, it said uplink-1. That means that someone actually had entered in something like this. And actually, it would have been, essentially uplink 1 here, uplink 2 over here. So these are just variables that actually, when you configure the node itself, you map over to an actual physical interface. In my case, I like to do M1, M2, M3 for my name, Mike, just so that I can kind of illustrate the point that this can really be just about anything. So basically what I have now is I have 4 uplinks that are going to be active, active, active. Transport VLAN, this is going to be my TEP VLAN. I'm going to make this VLAN 19, and I'm not going to set the MTU because the global MTU is already 1600, so I'm good with that. So I'll leave that as is. So I'm going to hit add. All right, so we got our profile created, so I think at this point we're pretty much ready to go ahead and configure our first transport node. So I'm going to do these independently just so you can kind of see the process. We'll go through it a couple times. So I've got the node selected. I'm going to hit configure NSX. I'm going to leave all of this to the default. As I mentioned before, we're going to do the converge VDS route. So I'm going to leave it set to VDS. And just to be clear, when I say you see prod VDS here, if I go back to vCenter and we look at our networks, this is prod VDS. So this just means I'm going to leverage that VDS. I'm not going to deploy a new virtual switch on my host. So I'm going to select prod VDS. I've got my transport zones created already. I'm going to select overlay, and that's all I need for the actual host. I know you're probably thinking, I did create the Edge VLAN one, but that is only for the Edge VM, and we're going to get to that in a later video. So all I need on the host is actually the overlay transport zone. And as mentioned, it comes with the default, so I could actually use this one right here. And you can also attach multiple transport zones to a host. So there's no big deal about doing that. Uplink profile, we're going to specify the one that I selected already, MGTN profile v19. For IP, I'm going to go with DHCP. And then I'm going to map all of those links. You remember I selected M1, M2, M3, and I made them all active. Well, now you see, since I deselected failover order and selected load balance source, now these are all active, active. All I'm going to do is map these over 1 to 1. So M3 to uplink 3, M4 to uplink 4, etc. That looks good. I'm going to hit finish. All right. So while that one's going, I'm going to go through the second one really quick, and then we'll just wait a minute, and hopefully these will finish relatively soon. All right, so our host prep was successful, as we can see here. Now it's showing 1 host switch per host. So if I click on that, you'll actually see prod VDS, and it shows the transport zones associated with it, the uplink profile, all of that. So that's good. We don't see any errors here, no alarms, so we're good to proceed from here. Now I do want to show you guys something real quick. You saw that it took a little while for that to complete. So what it was doing is actually pushing VMware installation bundles, or VIBs, onto the host that actually enable all of the NSX functionality. When I say NSX functionality, I mean the virtual switching, routing, firewalling, IDS, IPS, all of the management components that allow the host to talk to NSX-T manager, etc. So I don't want to just show you guys just this magic box and say, look, it's green. I'd like to actually go in and prove it. So what I'm going to do is we're going to go SSH to one of our hosts. We'll SSH to 254.11. I do need to enable SSH on it. However, I don't think I have it enabled. So I'm going to set that up real quick. We'll go down to services. And we're just going to start SSH real quick. That's running. And we'll put in our credentials. All right, so now we're SSH into the host itself that we just prepped for NSX. Now, if I can remember the command, and that itself, that's anybody's guess right now, but I'll see if I can try. So it should be ESX CLI software vib list. And I'll show you guys the whole list first, if I got it right. Oh, wow, I got it. All right, so let me just come down here and actually make it so it's a little more readable. All right, so you can see here, what this command does is list all of the VIBs or installation bundles that are actually installed on the host itself. Now you probably saw there was a couple of NSX ones, and to make that a bit more readable, I'll rep NSX only. Now these VIBs that pop up here, these were not present on the host prior, and to prove that, let's actually, we'll pick one of these hosts. How about 254.13? Let's start that, because we haven't prepped this host for NSX, and we don't plan to, by the way. But this is just to illustrate the point. So let's hop onto this one. All right, so we got that. Now I'm going to grep NSX. So I'm doing the same command I did on the host that we just prepped. Although in this case, you can see there's no VIBs. So that's what you're doing when you actually do that prep and you say configure NSX. It is worth mentioning that that's non-disruptive. It doesn't bother anything on the host, and the overhead is extremely small. We're talking about very, very small packages being installed on the host. So it's not like your host needs to be in maintenance mode or anything like that. So that's all I have for you guys today. We will come back and look at some of this stuff as we move on through this series. The next step is getting to the really fun stuff, which is where we're going to configure our edge nodes. And once we have those done, we're ready to do routing configuration. And to be quite honest with you, once we get past the edge, all of the hard stuff is done. The routing in NSX is super simple. All of the security policy is super simple. So I think you guys will really dig it. I will say that if I can figure it out, trust me, you guys got this on lock. So I'm going to end the video here, and I'll see you guys at the edge configuration. Bring some energy drinks. It's going to be awesome.